In the previous lecture, we discussed a non-parametric method called the sign test. Today, I'm going to introduce another method called the Wilcoxon signed rank sum test. Well, it is related with the testing for location of a single population. I mean, it is related with the chapter 7 testing. Here's an example. It is the same example. Remember, this is a cookie bag is supposed to be 200 gram. In order to test that, we collect a sample like that. Well, instead of sign, the Wilcoxon signed rank sum test use the rank data. Let's look at how they generate the rank data. We want to test that whether the median, okay, is a central location of parameter. Since we are not calculating mean, well, it is reasonable to assume median equal 200 or not. It's a two-sided test. Then in case of a sign test, we check that whether it is above H0, m equal 200 or not. Okay, I mean these two data has a positive sign, these two data negative sign, plus sign, negative sign, and plus sign. But here, Wilcoxon proposed this idea. Rather than just the sign data, why don't you calculate the difference from data to 200? Okay? Well, it's some kind of distance, and the distance look like this. Subtract 200. Okay, it's 3. Well, this one will be 4, but this one is negative 3. But let's take absolute value. We are curious only distance first. Well, similarly, this is a negative 5, and taking absolute value is 5 like this. What do you expect? From here, we consider, I mean, these are related with the positive sign. It is above the 200, and then we call this is the positive data. Okay. Well, this is positive data. These are the negative data. Positive data, negative data. What we are doing is give them a rank. Okay. You have 2 ones. Therefore, you are supposed to give 1 and 2 each of them. But since there are ties, we just take average of them, 1 and 2. It becomes 1.5. Assign 1.5, but be sure in case of a positive sign, I gave the color the red. In case of a positive sign, well, we collect the red color as, okay. In case of a negative sign, we keep the black color. What's next after 1? This is the third one. The rank 3 will be assigned here, but it has a negative sign. Then what's 4? You have the next one would be 3, but you have 3. Therefore, you are going to assign 4 and 5, but since there are tie, you take average of that rank 4.5. But since we have a positive sign, I give the red color. This is black color. Similarly, after 4 and 5, it's time to give rank 6, 7, well, 8, well, there are tie, therefore you give 7.5, and so on. Maybe 9, next one would be 9. This one would be the highest number. I'll give rank number 10. Then we just collect the positive rank, okay? The red rank. What is the rational? Okay. Suppose, I mean, in case of sign data, we just count number of positive sign or negative sign. Here, we give them a rank. If H0 is true, the red rank, black rank, I mean positive rank and minus rank, well, they would be similar. Okay? Therefore, Wilcoxon proposed rank sum of positive sign. You may use a rank sum of a minus sign. It's the same thing. Okay? It is similar, the same conclusion. But let's keep the positive sign. We just add all these positive signed rank. It becomes 29.5. Then what you are supposed to do next? Wilcoxon check all possibility of this rank sum. Sometimes you have only one positive rank. Sometimes you have two positive rank, etc. They consider all kind of possibility of a positive rank sum and find the distribution like this. Okay? I mean, number of data with a positive sign. Well, here's a possibility. There is no positive sign data, and 1, 2, etc. And in each kind of combination of rank, okay, you have all possible rank sum like this. I mean, until here it is the same number as this one. In case of you have two positive sign data, there are this amount of possibility, 1, 2, 1, 3, 1, 10, 2, 9, 10. You have the all possible rank sum like this. Okay, 3, 4, 11, this is 5, 12, etc. They analyze probability of this. It look like this. It look like similar to normal. But in case of you don't have enough data, you have to use this exact distribution. What they are supposed to do? If your positive rank sum is located around here, these are the all possibility of rank sum. If it is located here, then you will accept H0. Depending on alternative hypothesis, if your rank sum is located here, we'll consider right tail test. If the alternative is less than, we'll consider this possibility. You know how to look up this table. Okay? I mean, this probability related with the cumulative probability from left to here. In case of, let's say, 5%, where is 5%? It's somewhere else here. Well, it's not appeared here. Maybe you can check later all kind of possibilities. And it's accumulated probability until here is 2.4%. Maybe it is close to 2.5 percentile around this value, 8 and 9. Let's see how they test. The decision rule based on that distribution is, the cumulated probability x is less than 8 is 0.2.544%. And this one is symmetric, therefore it is greater than 47, look like this. Therefore, somewhere else 8 and 9, if rank sum positive sign is less than 8.5 or greater than 46.4.5, then we'll reject. Okay? Since the positive rank sum is 29.5, it belongs to somewhere else between this number, therefore we cannot reject, we have to accept H0. Okay, let's practice this East and U, how they generate table. Here, testing hypothesis, non-parametric test. We are talking signed rank sum test. We want to test that it is 200 or not. Okay, median is 200 or not. Your data is, I copied that example data. It looks like this. If you click this, they automatically calculate positive rank sum and negative rank sum like this, and they find somewhere numbers. Okay? This is the red line is not exact critical line in case of discrete random variable. As a researcher, you have to decide it. Okay? Maybe somewhere here, well, you have to decide in case of 5%, you will decide that, as in the example, when they select 2.5% is in between 8 and 9, therefore you decide 8.5 is a critical line. Okay? This is right tail test is 46.5. Okay? Okay, that's it. I mean they showed this graph. You have to decide critical line. In our example case, it's around here. It's in the middle. It is definitely you have to accept H0. Well, if I summarize all these things, I mean, this output shows that you may use a testing hypothesis about the mean module in ESTAT, enter data like this, they're gonna generate a Wilcoxon signed rank sum test like this if you click this button. In summary, we have a table like this. Okay? You understand that we are using the positive rank sum. You have to look up this table in case of a right tail test. You have to look up only right tail, maybe depending on significance level, the alpha percent. This is the notation. This is left tail test. This is the two-sided test we just did before. Well, you know, the test statistic is a positive rank sum. If there is tie, as we did in the sign test, well, we will use that data for our test. Okay? Simply just remove it. Therefore, the number of data would be decreased. In case of a large sample, then you have to use a normal approximation. I cannot discuss in detail. It is a normal expectation of a rank, positive rank sum look like this. The variance look like this. We are using this information as usual G-test. Okay, that's all for signed rank sum test. Okay. We are using sign and rank sum to test. But be sure it is an easy test, but you are losing some information if you make some transformation. That means if your data satisfy some normality assumption, you'd better use parameter.